Hi, this is Pipesim Python Toolkit for beginners. In this video, you will find how to work with Pipesim tasks. Pipesim supports different tasks depends on what object is selected. It can be network simulation or network optimization task, or it can be PT profile simulation or nodal analysis for well or just flow line. In this video, I'm going to show you how to work with PT profile task. Each task can be split by two parts. First is the configuration, preparation, and the second is the execution. So I'm not going to cover the preparation in this video. I'm going to focus on the execution only. For this purpose, I selected the case study model, case studies well models CSV102. And this is the simple well model with predefined boundary condition and PT profile. We defined inlet pressure, outlet pressure, and the gas flow rate will be calculated. I run the simulation, and I have three tabs here. On engine console, I can see the general information about the simulation process. On the system results, I can see the simulation results, the key element which describes this well. And on profile results, I can find the detailed information about the simulation results. For each point of simulation, different parameters, and of course the different values. So what I'm going to do is I'm going to run the same task, predefined task in my PTK, and then extract some values. For example, from system profiles, I will try to extract the bottom hole pressure and temperature at wellhead. And I will use the table view to show you the value. And then I will try to get the same value from profile results. So let's go back to the PTK code. And first what I need is to know what really we have in our model. I know that this model contains the well, so I'm going to get the name of this well. Model, find, then use all components and filter model components by type well. So I can see that this model contains only one well with name well1. So I'm going to save this well name to variable well name. Now I'm ready to run the task. I use model, tasks class, and here you can see that tasks class has several subclasses, and I need to run PT profile simulation. Under PT profile simulation, you may find different methods. I'm not going to cover all of them right now. I want to focus on the execution, so I need to use this method run. In the run method, we have several arguments. The simplest way to run this model is to use only the first argument, where we need to define what's the name of the producer. So I will type the producer and then well name. And the result of this simulation will be simulation results, of course, and I need to save it in some variable. Results. Then I'm ready to run this. And let's wait when Pipesim finishes the simulations and returns the data in the results. So we have data in the results variable, and let's investigate it. Under the results, we have different properties. First property here is the cases. Let's check what we have. So the cases contains only one element, flow rate 22 million cubic feet per day. Let's see what we have in the user interface. In the user interface, we also can see that there is only one case, and the name of the case is the same. In this example, there is only one element because we have not run sensitivity. If we run sensitivity, we expect to have more cases. But I will use this output and assign it to the variable case. It will be used later. What else we can have? We can have here results, and then we have ASP curves. It's not used. Other curves, messages, states. Let's check state, for example. In the state, we have the output completed. It means that our simulation was completed. Result state is used when you run multi-thread simulation. So Pipesim Python Toolkit supports an option to run several tasks in parallel. And then you need to have some tool to control the execution process. And this can be useful. But in our case, I used run method, and I waited the simulation when the simulation was finished. And of course, the status of the simulation is completed. In addition to the state and the results, we can have the summary. So in the summary, you can see that this is the dictionary with keys info, error, and warning. and some additional information for each of them. So in info, we have the general information about the simulation process. Beginning, running with one core, and then finished. It's something similar what you can find in the engine console. Beginning and output. I think that that's enough for general overview, and we are ready to move on to simulation results. Let's start from investigating results. Here we have three types of results: system, node, and profile. I will start from the system. So if I print the result system, I can have this complex output. This is the number of the dictionary inside of the dictionary. Of course, you can use this structure as this, or you can convert it to the pandas object. I'm going to do it, and for this I need to import pandas spd. And now when the pandas is imported, I can create the pandas data frame. I will do it from dictionary, and then I will pass results system, and I need to do some orientation. Orient index. You can see user-friendly view of this dataset. We have only one case, flow rate 22 million cubic feet, and then in the rows we have the parameter name, Pipesim output diameter, system inlet pressure, and all others. Let me assign this output to system variable. System is assigned, and then we can try to extract the data from this pandas object. Let me try just to navigate it to the column case. So this is my output, and here I can select what's the row I need. If you remember, we checked in the system results bottom hole pressure and temperature. So I'm going to do the same in the PTK. For this, I can use system variables and bottom hole pressure. So the output is 2330, and the same value I have in the user interface. Let me try to use the same, but this time instead of the bottom hole pressure, I'm going to use well head temperature, and the output is 146. Let me check in the user interface. Yeah, we have exactly the same value. So we've got the option to extract the value from results. But originally we have a lot of different information, and we don't need all of them. Later I will show you how to filter it properly. The next thing I want to cover is results profile. When we type results profile, we have this complex structure. And again, the key element in this dictionary is the case name. So it's logically to filter it by using the case name. Since we have only one case, we have this dictionary where the key is the parameter name, and then some output is the list of the values. So we can work with it as this, or we can convert it to the pandas data frame. Let's do it again. Pandas data frame, then I type results, profile, and then case. And this is my user-friendly output. So we have in the column, we have the parameters, horizontal, total distance, branch name, and the value in the rows. And you can see that this table looks exactly the same as we have in the profile results. So the total distance, elevation, and all other things. Let me assign the output to profile variable, and we will see what we can extract from it. So profile is here, and if I want to get values at certain rows, I can use method ilog, for example, and return the output for the line 10. Here I have all these parameters. If I want to filter it, of course I can use profile variables, and then, for example, pressure. And this is the variable I need. So at the row 10, the profile variable is 1500. But I can also do another thing. I can type profile, because it's the pandas object. I will use the same pressure. And here I have the list of values for the pressure, starting from the completion and up to the wellhead pressure. Let me try to extract from here, for example, wellhead temperature. So instead of the pressure, I will use temperature. And this is my output, and I need to get the last value in this list, and this is the value I've got from the system. So it's up to you what type do you want to use. You can extract some value from the system, from the profile. You can work with original dictionaries, or you can convert them to the pandas object and work with it. But as I already told you, there is a way a little bit improve the performance of the simulation. Because I don't need all of these variables, I need to focus on the bottom hole, wellhead temperature, and maybe pressure and temperature in the profile simulation. So I have another option to run the simulations. Let me show you. I will use model, tasks, PT profile simulation, method run, and then I need to use producer again. So I set the producer, it's the well name, and then I have other arguments. I have profile variables and I have system variables. Let me try to enter profile variables, and I need to pass the list of the parameters. It will be profile variables, and here I have pressure. And another one is profile variables and temperature. And as a third argument, I will pass system variables. And again, I need to pass the list. System variables class, bottom hole pressure, and system variables class, wellhead temperature. And then simulation, I need to return the output to the results. Let me try to run it one more time. And I expect that this time the simulation will be much faster. The performance 2.1 seconds. The last time it was 6.7 seconds, so performance is a little bit better. And let's check what we have from output. Let me use the same structure to report to show you the results. So I'm going to use these for profile. And you see that in this case, the profile includes only necessary variables what we requested. It's the temperature and pressure. And if we copy the code from the system variables, we will see that the code also adjusted. So let me just copy this part of the code and type it here. So I report, and in this case, we have on the two rows, wellhead temperature and bottom hole pressure. So that's all what I wanted to show you here. And in the next video, I show you how to define PT profile tasks from scratch.